Dear students, this is session for flow through packed or fluidized bed. So it has good application in some food processing like drying, mixing, freezing, etc. It is a very conceptual topic, so try to learn this with good care. Flow in packed beds. A system of considerable importance in chemical and food process engineering fields is the packed bed or packed column. The packing materials in the bed may be spheres, irregular particles, cylinder, or various kinds of commercial packings. It is assumed that the packing is everywhere uniform and that little or no channeling occurs. We have container, suppose it is a cylindrical container, bottom is perforated. There are several holes, right? Materials of any shape, spherical, irregular, cylindrical, are kept in this cylindrical container up to height L above bottom. Fluid is flowing in upward direction through this packed bed. This is called packed bed, right? With some velocity. So guys, when it becomes a fluidized bed, it means solid particles kept in this container shows some properties of fluid. So this bed is called fluidized bed, right? कैसा बिहेवियर शो करने लगा? फ्लूइड के जैसा, not entirely, but it shows some properties of fluid like occupying the shape of container, flowing through notch or flowing over weir. These are properties of fluid. Here solid particles in this bed under fluidized condition shows this property. Solid particles in fluidized condition occupy the shape of container, flow over weir or through notch. So it has good application in the process of drying. In order to dry product in this container, drying gas is passing through its bed and removal of the water is taking place. For freezing and proper mixing, we use fluidized bed also, right? So guys, we have solid particles of any shape, right? Maybe spherical, cylindrical, irregular, or commercial packing like chocolate packing, right? So they are kept in this container. If we assume this container is circular, right? And D is the diameter. So total volume of this packed bed, cross-sectional area into height of the material in this bed, that is height of the bed. This total volume of the bed is occupied by solid particles. These are solid particles and void space, right? So total volume of this bed is volume of the void plus volume of solid particles. Now we see void fraction, voidage or porosity, epsilon. It is volume fraction of voids. That is the volume of void upon total volume of the bed. Volume of void is total volume of bed minus volume of solid particles upon total volume of the bed. 1 minus Vs upon V. Mass of this packed bed is coming due to mass of the solid particles only, because this packed bed contains solid particles and voids. Voids are filled with air. As compared to solid particles, air has negligible mass. So mass of this packed bed is due to mass of the solid particles only. So multiply numerator and denominator to this term by mass of the solid particles kept in this bed. 1 minus Vs into Ms upon V into Ms. Ms is mass of the solid particles. 1 minus Ms upon V. Total mass of packed bed is due to mass of the solid particle. So we can say Ms is the mass of packed bed in this volume V. Ms upon V. This is called bulk density. Into Ms upon this Vs. 1 upon Ms into Vs. This mass Ms of solids are actually occupying volume of the solids only. ये mass Ms Vs volume में ही तो है, remaining void है. So this is called true or particle density, right? So 1 minus, this is bulk density. How to find bulk density? Remember, we used total volume of the bed, and particle density, mass of the solid upon volume of the solid. So bulk density upon particle density or true density, right? This is porosity, void fraction, voidage. याद रहेगा ना? This is fundamental definition. Volume fraction of the void, volume of the void upon total volume of the packed bed. And guys, this is 1 minus bulk density upon particle density. Concept से याद रखना इसको. Clear? Similarly, we are going to calculate volume fraction of solid particles. Vs upon V. This is volume fraction of solid particles. Solid particles का volume upon volume of the bed. It is V minus VV, Vs. 1 minus VV upon V, 1 minus epsilon. Right. So dear students, whenever it is required, Vs is required. So Vs, volume of the total solid is equal to 1 minus epsilon into total volume of the bed. Right? 1 minus epsilon into total volume of the bed. This is the volume of total solids. Density of the solid particle, it is mass of the solid particle upon volume of the solid particle. So density of the solid particle into volume of the solid particle. This is particle density. Density of the solid particle into volume of the solid particle. This will give mass of the solid particle. Right? This is mass of the solid particle. Right? So rho p, density of the particle into 1 minus epsilon, and for cylindrical container, cross-sectional area A, height of the bed. So guys, this is a very useful formula to calculate mass of the solid particles in the packed bed. Density of the particle, solid particle, 1 minus epsilon, cross-sectional area into height of the bed. ये जो है ना कोई याद करने की जरूरत नहीं है, मैंने कॉन्सेप्ट से समझा दिया. Right now we define a specific surface area of a particle. This is solid particle kept in bed of any shape. This is irregular shape. Surface area of this particle is Sp, and the volume enclosed by this closed surface is Vp. The ratio is called a specific surface. Surface area per unit volume of the particle, Sp upon Vp. Its unit is 1 upon meter. This is in meter square and this is in meter cube. So its unit is 1 upon meter. Right? Surface area of the particle upon volume of the particle. For a spherical particle, surface area pi dp square and volume pi dp cube upon 6. So 6 upon dp is a specific surface of a spherical particle kept in packed bed. AV is equal to 6 upon dp, where dp is the diameter of a spherical particle. Right? So for this, actually it is coming from this fundamental definition of a specific surface, Sp upon Bp, 6 upon dp. And for non-spherical shape, it is Sp upon Bp. This is the fundamental definition. Dear friends, we can use this special relation for AV for a spherical particle, for non-spherical particle also. So we need to calculate effective diameter of non-spherical particle. Right? We make a non-spherical particle equivalent to a spherical particle by using equal AV for both. This is non-spherical particle and its equivalent spherical particle of diameter dp. They have same AV. Its AV is 6 upon dp and its AV is surface area is SP and volume is VP. SP upon VP. So equate these two AVs. SP upon VP is equal to 6 upon dp. So here we get dp 6 VP upon SP, where SP and VP are related with this non-spherical particle. So guys, this is equivalent spherical shape corresponding to this non-spherical shape, and dp is its diameter. It is equivalent because it has same AV of this actual non-spherical particle. दोनों के AV को इक्वेट कर दे तब वो जो dp हमारा आया है वो ये हो जाएगा. अब फिर जो है ना हम यूनिवर्सल ये फॉर्मूला सबके लिए यूज कर सकते हैं. 6 अपॉन dp. dp is the direct diameter of a spherical particle. For non-spherical particle, dp is calculated like this. dp is calculated by equating SPVP to 6 upon dp, right? So it is very clear. Now we define A. A is total surface area of particles in the bed upon total volume of the bed. Total surface area of the particle. All particles constitute what surface area? That is total surface area of the particle. We add surface area of individual solid particles to get total surface area of the particles. ये हमारे एक्चुअल इंटरेस्ट का है. अगर ड्राइंग भी होगी तो मॉइस्चर जो है ना हर पार्टिकल के सरफेस एरिया पर होगा. तो टोटल कितने सरफेस एरिया पर मॉइस्चर होंगे? जितने सॉलिड पार्टिकल्स के सरफेस एरिया है उतने पे होंगे. So it has great importance in food processing, right? Total surface area of solid particles upon total volume of the bed. It is equal to a specific surface area into 1 minus porosity. A is equal to this. प्रूफ कर देते हैं. This is total surface area of particles, right, upon total volume of bed. This is A na. AV is surface area of the particle, right? Surface area of particle upon volume of the particle. पार्टिकल की एक पार्टिकल की वॉल्यूम और एक पार्टिकल की सरफेस एरिया. एंड 1 माइनस एप्सिलॉन ऑलरेडी हमने डिफाइन कर दिया था ना. दिस इज वॉल्यूम फ्रैक्शन ऑफ सॉलिड पार्टिकल्स. वॉल्यूम ऑफ पार्टिकल्स अपॉन टोटल वॉल्यूम ऑफ बेड, राइट? Dear students, surface area of particle upon volume of the particle, so they cancel each other. Surface area of the particle upon total volume of the bed. Left hand side and right hand side both are same, right? So guys, this A is AV into 1 minus epsilon. A specific surface into 1 minus epsilon, right? And AV 6 upon dp. dp is the direct diameter of spherical particles. And if particles are not spherical, that is for non-spherical or irregular shaped particles, how to find dp we know. After equating AV for actual non-spherical particle and its equivalent spherical particle, right? So this is A, total surface area of the particle upon total volume of the bed. पूरे इंटायर वॉल्यूम में कितना टोटल सरफेस एरिया क्रिएट हुआ? So total surface area is equal to A times total volume of the bed. Total surface area created in the entire bed over which fluid is flowing, right? So क्या हो जाएगा? A times total volume of the bed. A times total volume of the bed is total surface area created, right? A, अगर A मुझे पता है, नहीं भी पता है तो हम ऐसे कैलकुलेट कर सकते हैं, इसमें टोटल वॉल्यूम से मल्टीप्लाई कर दीजिए, टोटल सरफेस एरिया कितना क्रिएट हुआ सारे पार्टिकल्स के सरफेस एरिया को ऐड करने के बाद, दिस इज इंपॉर्टेंट, वो कैलकुलेट हो जाएगा. दिस इज प्रॉब्लम. A packed bed of volume 1 meter cube is composed of cylinders having a diameter d is equal to 0.02 meter and length is equal to diameter of the cylinder also. The bulk density of the overall packed bed is 962 kg per meter cube and the density of the solid cylinder is 1600 kg per meter cube. Calculate the value of A. We need A, right? So for A, we need AB and epsilon. Porosity is 1 minus bulk density upon particle density, right? 1 minus bulk density of bed is 962 and particle density, particle is cylinder, right? So it is 1600. AV is SP upon VP. SP, surface area of cylindrical particle, surface area of curved portion plus area of two circles at the top and bottom. So 2 times pi dA square upon 4, top and bottom circular surface area plus pi d into height of the cylinder, length of the cylinder. It is also equal to diameter. So this is surface, total surface area of the cylindrical particle. सिंगल एक सिलिंड्रिकल पार्टिकल का हो गया और वॉल्यूम कितनी होगी? पाई डी स्क्वायर, बेस एरिया पाई डी स्क्वायर बाई 4 इंटू हाइट. हाइट क्या है? डी के बराबर है, राइट? सो वी हैव कैलकुलेटेड ए वी, epsilon, then we get A, total surface area per unit volume of the bed. Dear students, here we have two velocity. First, interstitial velocity between particles in the bed, V, and V prime, superficial velocity based on the cross-section area of empty container, right? Dear friends, this is container filled with solid particles, filled with solid particles. ये solid particles से हमारा filled है. So flow area is less in this condition. Fluid is flowing through interconnecting voids, right? So flow is taking place through this. Cross-sectional area, total cross-sectional area is not available for flow. So velocity of flow through packed bed is V, and it is called interstitial or true or actual velocity of flow, right? Cross-sectional area is suppose A. Now we are going to define another velocity based on empty cylinder or container. The whole cross-sectional area is available for flow in this case of empty container. The whole cross-sectional area is available, right? So this velocity is called superficial velocity, and it is defined on the basis of cross-section of empty container. Dear friends, mass flow rate of fluid is kept same in both cases. Mass flow rate of fluid is kept same in both cases. So here m dot is mass flow rate of the fluid when container is empty. So entire cross-sectional area is available for flow. Density of the fluid cross-sectional area, whole cross-sectional area, empty container into this, right? But in this case, total cross-sectional area of the container is not available for flow. Suppose A V, that is area created by void on a surface on a cross section is available for flow. So ये AV हमारा available है, इसी के थ्रू हो रही है, और ये कम है, लेस है ना. So here it is rho AV into V, right? Rho AV V is equal to rho A, right? Multiply both sides by height of the container. So dear friends, AV is area in cross section which is empty, not created by solid particles. We take a cross section, so area in this cross section due to void is this plus this plus this plus this, not this area. बात समझ में आए? यहां समझो, this AV, that is the area constituted in a cross section due to presence of voids only. So ये area plus ये area plus ये area, not this area, this area, this area. इस क्रॉस सेक्शन में ये एरिया सॉलिड पार्टिकल्स के द्वारा है, और ये वॉइड के द्वारा है, राइट? सो फ्लो वॉइड के थ्रू हो रही है, तो ये किसी क्रॉस सेक्शन में इसको बता रहा है. इसी प्रकार जो है ना हम एल से जो है ना मल्टीप्लाई कर देंगे, टोटल जो है ना वॉइड की वॉल्यूम को बता देगा. ये एवी इंटू एल, वॉल्यूम ऑफ द वॉइड, and cross section area into L, that is height. This is total volume of the bed. Total volume of the bed, ये total volume of the bed हो गया ये, right? Density cancel करो, volume of the void upon total volume of the bed, right? इसको जो है ना इधर लेके आया, तो क्या आया, right? So this is porosity. Clear? So interstitial or actual velocity V is equal to superficial velocity based on cross section of empty container. This is superficial velocity, right? So if epsilon is always less than 1, so V interstitial velocity is always greater than superficial velocity. So this is the relationship, remember. Sometimes, guys, we calculate our porosity by knowing the values of interstitial and superficial velocity. Interstitial velocity, that is the actual velocity of fluid through interconnecting voids. This is actual case for flow through packed bed, right? And superficial velocity is velocity of flow based on empty cross section, right? Based on cross section of the empty container and how they are related, we have obtained a relationship. Remember, interstitial is always greater than superficial. So interstitial V is equal to superficial V prime upon epsilon porosity. Now we define hydraulic mean diameter D. Hydraulic mean diameter D. This is definition related to fluidized bed. 4 times volume of void available for flow upon total surface of the solids. 4 times volume of the void available for flow upon total surface area of the solid. Total surface area of the solid. Right? Total surface area of solid. Divide numerator and denominator by total volume of the bed. Volume of the void upon volume of the bed. Total surface area of solid particles upon total volume. This is called A. And this is porosity. So 4 times porosity upon A. Right? Dear friends, this is called hydraulic mean diameter D, 4 epsilon upon A. Right? 4 epsilon. A is AV times 1 minus epsilon, and AV is 6 upon dp, right? And dp is diameter of spherical particles, and for non-spherical particles we can find dp by equating sp upon vp to 6 upon dp, right? रेनॉल्ड नंबर फॉर फ्लो थ्रू पैक बेड, जो फ्लो हो रही है उसकी रेनॉल्ड नंबर क्या होगी थ्रू पैक बेड. रेनॉल्ड नंबर ऑफ फ्लो थ्रू पैक बेड, guys, we know Reynolds number. This is most useful dimensionless number in flow. Rho Vd upon me. Rho is the density of flow through packed bed. जो फ्लूइड पैक्ड बेड के थ्रू फ्लो हो रहा है उसकी यह डेंसिटी है. V is actual or interstitial velocity of flow through packed bed. D hydraulic mean diameter, and mu is dynamic viscosity of fluid flowing through packed bed. This is most fundamental definition of this Reynolds number, right? And we know each terms. This is the density of fluid flowing through the packed bed. This is interstitial velocity. Interstitial velocity is superficial velocity based on cross section of empty container upon porosity of the bed. Hydraulic mean diameter 4 porosity upon A, which is 6 upon dp, or AV times 1 minus epsilon upon mu. So we are not going to memorize this relation because we know the expression of Reynolds number. Just refine your concept related to this topic. Here rho is the density of the fluid, V is actual velocity of fluid, which is interstitial velocity because flow is taking place through wide spaces, right? And it is obtained by this relationship. And here D is the hydraulic mean diameter, and how to find hydraulic mean diameter in this topic, this is the way. And mu is dynamic viscosity of fluid flowing through the packed bed, right? Suppose flow through the packed bed is laminar, so we can calculate pressure drop of the flow. Fluid is entering at the bottom and leaving the bed at the top. So it is entering to the bed at high pressure and leaving at low pressure. Pressure reduces due to drag provided by surface of the solid particles in the packed bed. जो पैक बेड में सॉलिड पार्टिकल्स है उसके सरफेस के द्वारा, बिकॉज फ्लो इज टेकिंग प्लेस ओवर द surface of the particles in the packed bed, so drag is acting on solid particles, and due to this drag, pressure drop is taking place of this flowing fluid. So pressure drop, pressure at bottom minus pressure at the top, fluid is flowing through packed bed from bottom to top, right? So at bottom pressure is high and at top pressure is low. So pressure at the bottom minus pressure at the top, this is pressure drop of the flowing fluid. If flow is laminar through the packed bed, Hazen-Poiseuille formula is utilized in order to calculate the pressure drop of the flowing fluid. 32 mu VL upon dA square, right? We know this formula from the fluid mechanics. So again we are not going to memorize pressure drop in flowing fluid for laminar flow through packed bed. Guys, we use this fundamental formula which is most useful for laminar flow through pipe. This is important for our GATE examination from fluid mechanics part. तो वहां से ये हमें याद रहता ही है, तो हम क्यों जो ना हाई वाला याद करके जो ना समय बर्बाद करेंगे, अपनी मेमोरी गंदा करेंगे. म्यू dynamic viscosity of the flowing fluid, v interstitial velocity, v prime upon epsilon, delta L height of the bed, this is hydraulic mean diameter. तो ये आपका इतना आ रहा है 72 म्यू v प्राइम. अब इसके जगह पर 150 कर देंगे तो ब्लैक कॉजनी इक्वेशन बन जाएगा फॉर लेमिनर फ्लो, राइट? शेप फैक्टर phi s. For irregular particles, the shape is usually represented by shape factor or sphericity, denoted by phi s, and it is defined as the surface area per unit volume of equivalent sphere of the same volume as particle divided by the surface area as particle divided by the surface area per unit volume of the particle, right? So dear students, we have irregular shaped particle. SP is the surface area of this irregular particle and VP is the volume enclosed by surface area SP, right? Its equivalent sphere is this and it has diameter dp. Its equivalent sphere is this. Actually particle is non-spherical in shape and its equivalent spherical shape is of diameter dp. Equivalency is defined on the basis of equal volume. Both have equal volume. पहले वाला में हमने जो डायमीटर निकाला था इफेक्टिव डायमीटर डीपी यूज्ड इन एवी 6/dp, तो वहां पर एवी को इक्वेट किया था. यहां हम वॉल्यूम इक्वेट करते हैं. दोनों की वॉल्यूम सेम है, इसकी वॉल्यूम और इसकी वॉल्यूम सेम है. आफ्टर इक्वेटिंग volume of actual non-spherical particle and its equivalent spherical particle of diameter dp, right? Dear students, find sp upon vp of this equivalent spherical particle. sp upon vp, यहां कैलकुलेट करो sp upon vp और यहां कैलकुलेट करो sp upon vp. यहां sp upon vp क्या हो जाएगा 6/dp, राइट? 6/dp. इनके रेशियो ही स्फेरिसिटी कहलाता है, यानी कि एवी का रेशियो स्फेरिसिटी कहलाता है, राइट? सो 6/dp डिवाइडेड बाय दिस sp upon vp. vp चला जाएगा ऊपर, 6 times vp upon sp dp. This is sphericity, right? Dear students, we know a specific surface area AV is equal to SP upon VP. SP upon इस नॉन स्फेरिकल शेप की स्पेसिफिक सरफेस एरिया ये होती है, राइट। सो एसपी अपॉन वीपी इज इक्वल टू अपॉन 6 upon phi s dp, right? So here sphericity or shape factor phi s is given, right? And dp is the diameter of equivalent sphere. This equivalency is defined by equating volume of actual non-spherical particle and assumed equivalent spherical particle of diameter dp. तो ये dp हमारा वहां से निकाल के यहां पर पुट कर दोगे, ab निकल जाएगा. So here AB is equal to 6 upon phi s dp, right? So this dp is actually different from the dp used in this formula. Clear? यहां पर जो dp यूज हो रहा है ना, इससे ये डिफरेंट dp है. यहां पर जो dp यूज हो रहा है वो इक्विवेलेंट स्फीयर है, लेकिन दोनों का एवी इक्वल था. यहां दोनों की एवी इक्वल नहीं है, एवी का रेशियो ही फाई एस है, फाई एस आ गया इसमें. यहां पर वॉल्यूम इक्वल करके जो है ना डीपी निकाला गया है, राइट डियर फ्रेंड्स. सो इन दिस वे रिमेंबर दिस हाउ शेप फैक्टर कम्स इनटू पिक्चर, राइट. शेप फैक्टर जितना 1 के क्लोज होगा उतना ही इसकी स्फेरिकल नेचर विजिबल होगी, उतना ही स्फीयर के क्लोज होता जाएगा. हाउ क्लोज टू स्फीयर, राइट. नाउ टॉपिक स्टार्ट्स. फ्लूइडाइजेशन. Fluidization is a technique which enables solid particles to take some of the properties of fluid. Solid particles are packed in bed, right? So these are not fluid, but under fluidized condition of the bed, if bed is fluidized, so some fluid properties are actually shown by the solid particles kept in bed under fluidized condition. Fluidization is a technique which enables solid particles to take some of the properties of fluid. For example, fluidized solids will adopt the shape of the container in which they are held and can be made to flow under pressure from an orifice or overflow a via. Solids may be fluidized either by liquid or by gas. So flowing fluid is either liquid or gas through the packed bed. This phenomena give rise to a series of characteristics which are exploited in a wide range of food processing operations such as pressing, drying and mixing. अब कैसे जो है ना सॉलिड पार्टिकल्स जो कंटेनर में रखा हुआ है उससे गैस पास कराकर फ्लूइडाइज करा जा सकता है, गैस या लिक्विड फ्लूइड पास करा के उसे फ्लूइडाइज किया जा सकता है, फ्लूइड जैसा कुछ बिहेवियर दिया जा सकता है, राइट. सो कंसीडर अ बेड ऑफ पार्टिकल्स से ऑफ अ साइज सिमिलर टू अ सैंड. When a fluid is passed upward through the particles, right, particles are kept in container and fluid is passed through the packed bed in upward direction, the bed remains packed at low fluid velocity. Fluid velocity is low, so fluid is simply passing through interconnecting wires in upward direction through the packed bed. It is not displacing the position of the particles in the packed bed at low velocity. This is the situation. The particles don't move because drag provided by flowing fluid through the packed bed is very less, so it is not going to lift the particles. So particles are packed together, right? Particles are experiencing contact forcing from each other. They are packed together. चिपके चिपके हैं, सब सटे हुए हैं. However, if the fluid velocity is increased sufficiently, a point will be reached at which the drag force on the particle will be balanced by the net weight of the particle. So उस केस में जो है ना ऐसा होगा कि अब पार्टिकल स्टार्ट करेंगे मूव करना इन अपवर्ड डायरेक्शन, एक्सपैंड करेंगे, राइट. सो बेड की हाइट इनिशियली इतनी थी एट लो वेलोसिटी ऑफ द फ्लूइड फ्लोइंग थ्रू द पैक्ड बेड at this condition where drag force is almost equal to weight of the particles, drag force acting on the particle is equal to weight of the particle, so particle will start moving in upward direction. So spacing particle का बढ़ना start हो जाएगा, right? This is called minimum fluidizing condition. अब ये जो है ना फ्लूडाइज्ड होने लगा, ये फ्लूइड जैसा कुछ बिहेवियर शो करना स्टार्ट कर देगा, राइट? A point will be reached at which the drag force on a particle will be balanced by the net weight of the particle. The particles are suspended in upward moving fluid and move away from one another. This is the point of incipient fluidization beyond which the bed is said to be fluidized. The superficial fluid velocity in the bed at the point of incipient fluidization is called the minimum fluidizing velocity, UMF. This is minimum fluidizing velocity where particles are just starting to move in upward direction by overcoming its weight with aid of drag force acting in upward direction. Drag force जो upward direction में flowing fluid के द्वारा लग रहा है, उसके द्वारा weight balance हो गया, तो थोड़ा सा और बड़ा तो आप समझ मूव करना स्टार्ट कर देगा, राइट? So the velocity at which this situation creates where drag is sufficient to lift the particle. So particles are suspended in moving fluid. They are separated from each other almost, right? So there are no intergranular forces acting between particles. So that velocity is called minimum fluidizing velocity, and height of the bed at minimum fluidizing condition is LMF and porosity epsilon MF, right? Minimum fluidizing porosity, minimum fluidization height of the bed, minimum fluidizing velocity of the flow, right? And this is superficial velocity. At velocities in excess of दिस मिनिमम फ्लूइडाइजिंग वेलोसिटी, अब मिनिमम फ्लूइडाइजिंग वेलोसिटी से ज्यादा वेलोसिटी अगर बढ़ेगा तो दो केसेस राइज होंगे, राइट? पार्टिकुलेट फ्लूइडाइजेशन एंड बबलिंग फ्लूइडाइजेशन. दिस इज वेलोसिटी ऑफ फ्लूइड रिक्वायर्ड फॉर फ्लूइडाइजेशन, मिनिमम वेलोसिटी ऑफ द फ्लूइड. So it is called minimum fluidizing velocity of the fluid. It is superficial velocity based on cross section of empty container. Clear? तो ये वेलोसिटी उस समय जब मिनिमम फ्लूइडाइजिंग कंडीशन है, सेपरेटेड है, उस समय पोरोसिटी है, और ये क्या है? उस समय हाइट कितना है बेड का. अगर वेलोसिटी ऑफ फ्लो इस मिनिमम फ्लूइडाइजिंग सुपरफिशियल वेलोसिटी से बढ़ेगा तो दो डिफरेंट फेनोमेना आपको देखने को मिलेगा, पार्टिकुलेट फ्लूइडाइजेशन and bubbling fluidization, right? So here velocity of flow is less than minimum fluidizing velocity, right? So this is the height of bed at this time. Epsilon is the porosity, right? Dear students, when the velocity of flow is equal to minimum fluidizing superficial velocity, so here particle will expand in upward direction, right? Its porosity changes and it is called minimum fluidizing porosity, and this is called minimum fluidizing height of the bed, right? Increase the velocity of flow through the packed bed beyond this minimum fluidizing velocity, further height of the bed increases to this value and another porosity, right? So here there is no any bubble formation. This is called particulate fluidization, and this is actually happening if fluidizing medium is fluid. अगर fluid इसे पास करेगा तो इस तरह का मिलेगा। वही अगर गैस पास करेगा तो जैसे ही मिनिमम फ्लूइडाइजिंग कंडीशन अचीव कर लिया, इसके बाद पार्टिकल जो है ना एक्सपेंड नहीं करेंगे, वेलोसिटी आप इंक्रीज करो। इफ वी इंक्रीज वेलोसिटी बियॉन्ड मिनिमम फ्लूइडाइजिंग कंडीशन, इट इज नॉट गोइंग टू स्पेस पार्टिकल्स। सो हाइट देख के दोनों का सेम लग रहा है। एक्सेस एयर flows in the form of bubble like this। ठीक है, फ्लूइडाइजिंग मीडियम हमारा यहां पर क्या है, गैस है। सो दिस इज बबलिंग फ्लूइडाइजेशन। जनरली बबलिंग फ्लूइडाइजेशन अकर्स इफ फ्लूइडाइजिंग मीडियम जो फ्लोइंग फ्लूइड है वो गैस हो। ये क्लियर। मिनिमम वेलोसिटी एंड पोरोसिटी फॉर particulate fluidization, everything already I have discussed. Just read out these all statements. When a fluid flows upward through a packed bed of particles at low velocity, particles remain stationary. At low velocity, particles remain stationary. As the fluid velocity is increased, the pressure drop increases. Upon further increase in velocity, condition finally occur where the force of the pressure drop times the cross-sectional area equals the gravitational force on the mass of the particle. Then the particle begin to move, and this is the onset of fluidization or minimum fluidization. जब ड्रैग फोर्स जो प्रेशर ड्रॉप फ्लोइंग फ्लूइड इनटू क्रॉस सेक्शनल एरिया द फ्लो वो जो है ना वेट के इक्वल हो जाए, तो अब जो है ना क्या हो जाएगा कि पार्टिकल जो है ना बिगिन करेंगे मूव करना। पार्टिकल्स बिगिन टू मूव इन अपवर्ड डायरेक्शन, इन द डायरेक्शन ऑफ फ्लो। The fluid velocity at which fluidization begins is the minimum fluidization velocity. It is always defined on the basis of cross-sectional area of empty container. Superficial velocity. The porosity of the bed when the true fluidization occurs is the minimum porosity of the fluidization. Epsilon mf, minimum fluidizing porosity. The bed expands to this voidage or porosity before particle motion appears. This minimum voidage can be determined experimentally, right? As stated earlier, the pressure drop increases the gas velocity. As gas velocity is increased, pressure drop increases as the gas velocity is increased until the onset of minimum fluidization. Then as the velocity is further increased, the pressure drop decreases very slightly, right? So everything we have discussed. Now we see here, we have case number 1, right? So up to this height, case number 1, up to this height, solid particles are kept in this container, right? And epsilon 1 is the porosity of the bed in case 1, right? And fluid is flowing through this bed, and u1 is the velocity of flow. Case 2, u2 is greater than u1. So definitely guys, if 2 is condition of minimum fluidization or above minimum fluidization, so definitely particle will expand and the height of the bed will increase. So L2 and epsilon 2 is the porosity in the second case, right? In both cases, total mass of the bed, which is actually due to mass of the solid particles, are not changing. So we equate total mass of the solids in both cases, we'll get a good beautiful relationship. दोनों केस में सॉलिड पार्टिकल्स का मास तो सेम ही है, एक्सपेंड हुआ है बट बाहर गया तो नहीं ना है, मास सॉलिड पार्टिकल का इक्वेट कर दो। हाउ टू कैलकुलेट टोटल मास ऑफ द सॉलिड इन केस 1, वी नो। क्या बोला था मैंने, डेंसिटी ऑफ द solid particle into volume of the solid particles, right? It is 1 minus epsilon 1 into total volume of this bed. Suppose A is the cross sectional area of this circular container, so A L1। ये हमने पहले भी स्टार्टिंग में ही डिस्कस कर दिया था, क्योंकि हमने बोला था ये बहुत यूजफुल होने वाला है। डेंसिटी ऑफ पार्टिकल 1 minus epsilon 2 क्रॉस सेक्शनल एरिया सेम है बट लेंथ L2 हो गया है। मास ऑफ द सॉलिड पार्टिकल्स इन केस 1 एंड केस 2 सेम, दोनों को इक्वेट करो, रिलेशन क्या मिलेगा, ये कैंसिल हुआ, 1 माइनस इप्सिलॉन 1 L1 इज इक्वल टू 1 माइनस इप्सिलॉन 2 L2, राइट, वी नो इप्सिलॉन 1 L1 इप्सिलॉन 2 L2, राइट, बात समझ में आया, राइट। If there is no information regarding porosity in initial condition in the problem, अगर गेट प्रॉब्लम में इनिशियल पोरोसिटी के बारे में कुछ बोला नहीं गया है कि केस वन में इनिशियली क्या पोरोसिटी है, तो हम समझेंगे दिस इज अ कंपैक्ट बेड, कंपैक्ट बेड समझेंगे, कंपैक्ट बेड हैज नो वॉइड्स, सो वॉइड फ्रैक्शन वीवी अपॉन वी इज ट्रीटेड एज जीरो, जीरो ट्रीट करेंगे, राइट, इसको जीरो ट्रीट करके आप क्वेश्चन में ये जो सॉलिड पार्टिकल का मास दिया हुआ है वो पता हो, डेंसिटी ऑफ द पार्टिकल दिया हो, सो हाइट ऑफ द बेड कितना होगा इनिशियली वो कैलकुलेट कर लेंगे, राइट, वो हमारा L1 निकल के आ गया, ये आपका जीरो है, सो L1 इज इक्वल टू 1 माइनस इप्सिलॉन 2 L2, राइट। सो ये रिलेशनशिप आपका बहुत इस्तेमाल होने वाला है, क्योंकि जितने सारे गेट के प्रॉब्लम है उसमें इनिशियल आपका जो है ना दिया नहीं है, आपसे पूछा जाएगा कि भाई सेकेंड सपोज कर लो जो है ना फ्लूइडाइजिंग कंडीशन है, राइट, सो L इज इनिशियल कंडीशन में हाइट बेड का कितना है, और सेकेंड हमारा फ्लूइडाइजिंग मिनिमम फ्लूइडाइजिंग कंडीशन है, सो 1 माइनस यही बन जाएगा एप्सिलॉन एमएफ, this is LMF, right, minimum fluidizing height of the bed, minimum fluidizing porosity. If minimum fluidizing height of the bed is given in the problem and problem may ask this minimum fluidizing porosity, L is not given in the problem, generally initial height of the bed is not given in the problem. So guys, how to find L, that is the height of the bed initially before minimum fluidizing condition. So mass of the solid, density of the particle, 1 minus porosity initially, 1 minus porosity initially, cross sectional area into L. We are considering initially porosity is zero because there is no information, so we consider initially bed is compact, fully compact, right. So mass of the solid particles in the bed is always given, density of the particle, true density or particle density is given in the problem, right, cross sectional area of the container is given, so from this we can find the value of L. Initially height of the bed we can calculate from given relation, mass of the solid particles in the bed, density of the particles, right, and we are considering initially bed is compact, so porosity is zero, so from this we can find the value of L, put the value of L here to find the unknown, right. Mass of the solid in the bed, density of solid particle 1 minus epsilon and volume of the bed, right. Now we calculate pressure drop, pressure drop under minimum fluidizing condition, under minimum fluidizing condition we are going to calculate pressure drop. At minimum fluidizing condition, solid particles are suspended in air, solid particles are suspended in fluid flowing through the packed bed, solid particles are suspended, so we are considering a single solid particle, so drag force is acting in upward direction, drag force, right, solid particles are suspended in air, so buoyancy force is also acting in upward direction, right, and weight of the particle is acting downward direction, right, clear. So we consider entire solid particles, so total drag force, total buoyancy force and total weight, एक पर करो या इंटायर पर, all are suspended in flowing fluid, all particles are suspended in flowing fluid, so total particle पर drag force कितना लगा, buoyancy force कितना लगा, right, और वेट कितना लगा, सब मेजरेबल है. सो एफ डी प्लस एफ बी is equal to weight of solid particles in the bed, right? Drag force, it's a very simple to calculate. Drag force is calculated by knowing the pressure drop of the flowing fluid at bottom. At top pressure is P1 and here pressure is P2, right? यहाँ पर प्रेशर आपका क्या है, P1 है और यहाँ प्रेशर P2 है. So P1 minus P2 is pressure drop of the flowing fluid. P1 minus P2 pressure drop into cross sectional area. This is drag force. ये आपका जो है drag force है, right? So guys, drag force is equal to total weight of the solid particles minus buoyancy force, right? And drag force आपको पता है pressure drop delta P into cross sectional area of the container, delta P into a weight. We can easily calculate the weight of the solid particles. Density of the particle 1 minus epsilon under minimum fluidizing condition. We are actually calculating pressure drop under minimum fluidizing condition. जब minimum fluidizing condition है उस समय pressure drop, because at that time particles are suspended and the particles will experience buoyancy force. Particles are suspended in flowing fluid and so particles will experience buoyancy force. So under minimum fluidizing condition, porosity, right? Cross sectional area of the container into height of the bed. So this is weight. Now we calculate buoyancy force, FB. So separately we calculate FB. Buoyancy force is weight of the displaced liquid by solid particles. Weight of displaced liquid. Weight of displaced liquid by solid particles. Weight of displaced liquid. Density of liquid into volume of displaced liquid. Displaced liquid का volume कितना है? Density of the liquid weight into G. यहां पर जो ना ये मास आया है ना into G से मल्टीप्लाई करना है. दिस इज द मास ऑफ सॉलिड पार्टिकल इनटू G, वेट ऑफ द सॉलिड पार्टिकल. सो वेट ऑफ डिस्प्लेस्ड लिक्विड, वेट मास ऑफ डिस्प्लेस्ड लिक्विड इनटू G, mass of displaced liquid, density of liquid into volume of displaced liquid, right? Due to presence of solid particles in this fluidizing condition, displaced volume of liquid is equal to volume of solid particles. जितना solid particles का यहां पर existence है उस जगह पर liquid नहीं होगा, right? या जो ना जो फ्लूइड है, ये फ्लूइड जो फ्लोइंग फ्लूइड है, हम फ्लोइंग फ्लूइड अभी लिक्विड कंसीडर कर लिए, राइट? सो बायंसी फोर्स लिक्विड ना करके आप फ्लूइड बोल सकते हैं, डेंसिटी ऑफ द फ्लूइड एंड वॉल्यूम ऑफ द डिस्प्लेस्ड फ्लूइड. चलो लिक्विड से ही बात कर लेते हैं, क्योंकि लिक्विड और गैस दोनों फ्लो कर सकता है, तो इट इज बेटर टू राइट फ्लूइड, लेकिन मैंने लिख दिया तो रहने दो. डियर स्टूडेंट्स, सो वॉल्यूम ऑफ डिस्प्लेस्ड लिक्विड और फ्लूइड इज इक्वल टू द वॉल्यूम ऑफ सॉलिड. जितना वॉल्यूम सॉलिड का होगा उतने जगह पर फ्लूइड नहीं होंगे. सो वॉल्यूम ऑफ सॉलिड चाहिए मुझे यहां पर, वॉल्यूम ऑफ सॉलिड. सो डेंसिटी ऑफ फ्लूइड या लिक्विड, कंटिन्यूटी मेंटेन रखो, डेंसिटी ऑफ लिक्विड इनटू वॉल्यूम ऑफ सॉलिड पार्टिकल्स, वॉल्यूम ऑफ सॉलिड पार्टिकल्स 1 माइनस इप्सिलॉन under minimum fluidizing condition cross sectional area height of bed under minimum fluidizing condition. This is the volume of solid particles. उतना ही वॉल्यूम फ्लूइड का डिस्प्लेस होगा into this G. So this is buoyancy force. जरा यहां पर देखो, density of the particle 1 minus epsilon mf al G, density of fluid 1 minus epsilon mf al minimum fluidizing condition into G. तो क्या कर देंगे, ये माइनस जब इसको आप करोगे तो फाइनल रिजल्ट क्या मिलेगा, ये ए इधर से कैंसिल हो जाएगा, इसमें भी ए कैंसिल हो जाएगा, यू विल गेट प्रेशर ड्रॉप डेल्टा पी, density of the particle minus density of the flowing fluid, right? 1 minus epsilon mf, a cancel हो चुका है, l mf into g, this is the pressure drop, ये आपका प्रेशर ड्रॉप है। इससे भी जो प्रेशर ड्रॉप गिवन है तो इस तरह के क्वेश्चन गेट में आए हुए एलएमएफ निकाल सकते हैं, कुछ भी निकाल सकते हैं यहाँ पर, डेंसिटी ऑफ द पार्टिकल, डेंसिटी ऑफ फ्लोइंग फ्लूइड बोथ आर गिवन। सो हम जब प्रॉब्लम सॉल्व करेंगे तो ये सब कुछ देखेंगे, राइट? तो अनदर सेशन में हमारा प्रॉब्लम का सॉल्यूशन होगा। वी आर नॉट गोइंग टू अप्लाई एनी कॉन्सेप्ट आउट ऑफ डिस्कशन इन दिस सेशन, इससे बाहर मैं कुछ भी लगाने नहीं जा रहा हूं। ईच एंड एवरी कॉन्सेप्ट इज क्लियर, पूरी तरह से क्लियर है, एकदम क्रिस्टल क्लियर है, कोई भी झोल नहीं। सो एक्चुअली दिस इज ट्रांसिशन, रेस्ट ऑफ दिस सेशन।